guys, this is Emmanuel. So I'm starting a series on YouTube that is a LeetCode series from now till I think December. I want to be posting at me videos every day of me solving problems, algorithmic problems from LeetCode. So in this series, we are going to start from the easiest to the medium to the difficult. So we have a problem list here on LeetCode, and as you can see, we are going to be solving a lot. I already started solving just for practice sake. So yeah, the purpose of this series is not to pre-solve videos or train for videos and then come and record myself solving. It's for me to solve these problems in real time. So I'm not gifted in the algorithmic solving problems. So this is me, trying to gain experience in it by solving LeetCode problems. I solve problems good enough, but identifying patterns and making sure that I see enough problems that I can, solve future problems easily is one of my goals here. And also to provide a realistic point of view to people, you guys on YouTube and social media platforms, especially those who are new in the tech world and people who want to solve algorithmic problems too, of how engineers think of solving problems. I'm a software engineer by profession, and I'm also just recording the videos, just to start a YouTube channel and see where this goes. It's not necessarily to make money, but just to show my skills to people who are interested in, and also maybe this will bring collaborations with people who want to build interesting stuff to better the world. And then this is not the only series I'll be doing in this from November to December period. I'll also be doing two other series, so you find them in two other playlists. There will be the architectural design playlist, that's system architecture, system design and architecture. You'll find I'll fix the name later, but essentially in that playlist we'll be giving problems, right, and we'll be designing solutions, right, for those systems. And yeah, that's just basically system design, and we'll be seeing the tools. We'll be coming up with interesting design patterns and design strategies, and how deep we'll go with those designs will vary. More on this on the introduction video on that channel, on that playlist. And then the third one will be a full stack software development lifecycle kind of a video where we come up with we'll take one project, we'll be working on a project, and we'll take it from conceptualization, which basically I'll pick it, and then requirement gathering, we'll talk about requirement elicitations, everything about the requirements, things you could do. We'll talk about the designs, how we're going to design the different database structure, the system itself, and the different sectors of the system. Then we'll do implementation depending on my stack. And in this case, I was thinking of going with Java, since I am well versed with Java. I've built extensively with Java. But since we're going full stack and I want to do it, we'll be doing some other stuff. Now I know this is not the purpose of it, but this is the first feature we're putting out, so I just wanted to give the information here. And more on the full stack and how we go about it on the introductory video on that playlist. But for this one, so the first problem we're going to solve today will be the longest common prefix, right? And it's going to be easy. For the first few days, say maybe the first week, we're just going to be solving easy questions. Though they seem easy, they're not exactly easy. And the idea is we're going to solve them, and then we're going to test them. Then we are going to use ChatGPT to give us an optimized version, and we're going to compare it against our solution. And then I'm going to try to understand it, and then I'm going to try to explain the solution of ChatGPT and why it's better, and maybe prompt it to even tell us why it's better. That way, we don't just learn one solution, which is my solution. We also learn another solution, probably the most effective solution to the problem, which will be provided by GPT. And this is how we're going to learn and progress. So I hope these videos will not be as long as so long. I hope there will be a max for these algorithmic videos, especially for the easy ones, 1 hour, 30 minutes, 1 hour max. The medium same. The difficult ones, we'll see about 1 hour, 2 hours, something. Anyway, so let's dive into the first question. So here's a question for those who are new to LeetCode. It's a platform that allows you to it basically allows you to learn how to solve algorithmic algorithms, right? Programming allows you to learn how to program, allows you to improve your skills on algorithmic problems. And essentially, I have already skipped a lot of steps. I signed up, and then I'm in the problem section. So you can go to the LeetCode homepage and then go through the sign up process. But the first question is called the longest common prefix. Did I already start? Let me see. Yeah, so I kind of already started. I wanted to just see something. So as you can see, I'm just going to delete that. Well, I was solving, and then I thought I would do this. So there we go. I'm going to start back from here. Okay. So we're going to do longest common prefix. And the question states, write a function to find the longest common prefix string amongst array of strings. If there is no common prefix, return an empty string, right? And then they give an example. And so you have an array of string flower, floor, flight, and they say the output should FL, which in this case it means that F and L are common amongst the input array, and they are the longest combination of letters that are common, right, in the input array. And also they have to be consecutive, right? Now if you see there's FLO, but it's not present in the last one, the flight. So F and L are the longest. So it's same thing for example 2. There is D, there is R, and there's C. Now none of the prefix are common amongst each other. So you realize that there is no longest prefix here, right? Because each just appears once in its own string. So the explanation. Now the constraints, which is very important, states that the string length is greater than or equals to 1, and the string is less than or equals to, the string length is less than or equals to. So this, the array of strings, the length of the array of strings is less than or equal to 200. The second one is that the length of each individual string in the array of strings is less than or equals to 0, which means that each individual string can contain 0 characters or up to 200 characters within each individual string, right? And then the third constraint states that so each string consists of only lowercase English letters if it is non-empty, right? So if you have a string like this, you only have a lowercase letter, so you're not going to have an uppercase letter, which is good because then you don't have to try to convert all the letters into a lowercase to have consecutiveness and so to properly compare each string well. So usually we'll solve here, but anyway, I like to solve on IntelliJ. Yeah, it provides AI assistance, but we're going to use autocomplete, but that's not the point why I'm using it. I just prefer it. It also allows me to, the AI assistant is just for functions within certain classes, predefined classes in Java that I already use, right? So for example, the string, there are certain functions that you use. The LeetCode does not give you those functions, right? You need to probably know it beforehand or search it, right? So I prefer to solve it. So this is the definition of it. As you can see, I was already solving some previous questions in the past few days. So these are easy questions. So let's dive into it. So the first thing is, let's start with the first constraint. So they say the length of the string. So we are going to do, not sure why the menu down is not going, but these are the constraints. Right. Okay. So that's what we have. So yeah. Okay. So it states that so the string is, so the array of string is either is from 1 to 200, right? So you will not have a zero string. So essentially we want to say if, so you see the autocomplete there, but we're not going to use it, right? So we just want to do if string, sorry, if strs dot length, right, is equal to 1, right? We just want to return strs2, right? And that's what we want to do, right? Because basically the idea is if we have just one string in the array of strings, then the longest prefix is going to be 1, right? Because it is the only prefix that is there, right? The longest prefix is the entire string, is the most common prefix. At least that's how I imagine the solution of the problem. But if there are multiple, right? So if there are multiple, what do we want to do? We want to traverse, so I'm going to use comment to explain traverse the string. We want to traverse the array of string, right? That's the first thing, right? So how do we do that? We want to do for. Now we can do, okay, yeah, we can do this. Now we can do for integer I equal to 0, right? I less than, sorry, str. Now you see the autocomplete, right? We are going to be using them in the future to speed up the thing in the upcoming videos. But for now, we're going to try to make sure we don't use them. Now we can do this. This is really good. This is really good. But those who write Java, you can also do something like this, right? You can also do for string str, right? Strs. This is cleaner. And basically it's the same thing. It's just basically the same thing, right? You're traversing the string, and where it ends here is also going to end there. So we'll just use the one up. So remember that we see both cases. These and these are the same thing. They are doing this. They are the same purpose, right? They're traversing the string, and at the end it's going to break. So good. Now, what do we want to do when we traverse a string? Now, the thing is, remember we are supposed to find. So let me get the equation again, right? we are supposed to make sure that we're finding the longest prefix, right? So how do we find the longest prefix of the longest common prefix? Sorry. Now, the idea I have is that if we have a given number of, if you have a string like this, in order to find the longest prefix, we have to start here and traverse to the end. But we need to take into consideration certain things here. Well, so at the first, so we're thinking of the solution here. So let's just brainstorm. What I'm saying could be wrong, and until we get to the right answer. So we have to take this one and save it somewhere, right? And then we compare this one to this one. But if we are comparing every single word to each word, then we'll have a problem because they might not match, right? That means the entire word have to be the same, right? But what if, since we're trying to find prefix, which means that the first letters have to be the same, you get? If the first letters are not the same, as you see in the second example, where even if the second letters are the same, but the first letters are not the same, the output is empty. So because the first letters are the same, it makes the work easy that we are only interested in strings with the first letter the same. You understand? But now, so how do we do that? We need to say, okay, how do we do that? So we need to, first of all, consider comparing only the first letters of each string in the array, right? And the idea, if the right, only when the first letter match can we proceed to compare the other characters. Now, so basically this character. So a string is made up. A string is an array of characters. For those of you who are new to programming or computer, basically a string. This is a string, as you can see, right? And each individual letter like D, O, G are called characters. And so a string is a combination, a sequence of characters, an array of characters. We call them an array because they're in a sequence, right? They are next to each other. So it's a sequence of characters. That's what a string is. So when I say the first character, basically mean the first letter. Consider comparing only the first character. I'll just use shorthand. Okay, let me just character of each string in the array. Now, that's the idea. So, what do we do then? So, how do we make sure that each character is let me say the longest, right? And also remember that because we compare this one and this one, but this one, say this one does not have the same character. Let's just assume that this one was, let me say, might. Sorry. Let's say might, right? Does not mean that it cannot still be information here. Let's say something like that, right? Let's just say that's a word exists like that, right? Does not mean that you cannot still have another letter, which, because then this is MIG becomes the longest substring of F error. So we need to take that into consideration when writing that. So, but the first thing is we need to, first of all, since we're traversing a string, we need to compare every string. So we want to say, okay, how do we traverse issues? How do we say? So we're going to say, how do we traverse a string? So we have a string. You know what? Let me see. Let me try. I want to. Yeah, that's what I wanted. Okay. Just return. I just want to get something. So you understand. I'm trying to find something here. So just 1 minute. Let me guess. Common prefix. Let me make that static. Static. System. Print line. Yes. Prefix. Don't be alarmed. Yeah, okay. Okay. I was afraid that when you do this, you will not still have this. Like it will. I think this is a React property. Maybe I'm wrong. When you destructure, when I don't know, maybe I'm wrong. I think there's a programming language when you do something like this. Basically, then the original array does not always exist. I don't know. So it came to mind. So I was just testing if that's the case here. So don't worry about that. But yeah, okay. So we need to traverse the string. So right now we have the individual strings, right? And each time we traverse the string, we need to compare with the other strings, right? So we can, how do we do that? So we need a second for, right? Same thing, we can do that. So we can do for st, let's say compare, or let's say compare. Okay, sorry, the string compare strs, yeah, something like that. Okay, and then we want to say each time so the idea here is this: when we take the first string, we want to compare it with the second string and the third string, right? The first string is obviously going to start the same. So that's the first string, right? So the first string is definitely going to start the same. We want to take the first character of the first string and compare it with, say, the first character of the second string. And that's the idea. When we do the I plus 1, I plus 2, I plus 3, blah, 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 we can do that I plus 1. So we can do string compare I plus 1, then you take the second string compare I plus 2, string compare I plus 3, right? Okay, we should, but here we can still do the same thing. I'm going to do string compare. So the idea is if this first string dot okay. All right, so first of all, the original one will be string dot character at 0, right? Essentially, we'll do the start with later. For those of you who are not familiar with Java, string this one character 0 is equal to, right, dot character 0. So basically that's how you compare the letters, right? So this one is going to stay put while this for loop travels through the original array of strings and it's going to compare. If they are the same, if and only if they are the same, right, then we want to now compare as many of the characters as possible of that string itself. You understand? We want to compare the next character, we want to compare the next character and the other character. And in this case, we already have 3. So in order to compare the other characters, this, like I said, a string itself is an array of characters. And so we already have another for loop here. Again, so the beautiful thing about Java is that you have already made functions which you can use. So I'm going to do, if that's the case, you can do string so we are going to check so we want to compare and traverse a string the number of times the shortest character, the shortest length of this. Again, this is very long and there's a very easier way to do this, but let's just go with the basic ways, right? Loops and stuff. So we want to traverse the string itself. We're going to do, let's see, but which string are we traversing? You just choose anyone. So we want to compare the length of these two strings, right? And then we want to do a for loop that goes through as much as length. So I want to do a for int I equals to 0, right? I less than. So the idea here is we want to do a for loop, right? We want to do a ternary operator that returns. So we do if. So it's a ternary operator that says if so I want to return the lowest, right? So I want to do str.length, right? If str.length, right, is greater than com.length, right, then we want to return, I want to return comp.length minus 1, else str length minus 1. Essentially, we are traversing that string based on the shortest, because after the shortest, even if the other one continues, there will be nothing to compare it with. You get? So that does not matter. And so we want to do that, and then we're going to do I plus plus here. There we go. And that's how we want to traverse the string. But now we need a variable to hold our longest. So we want to do a string, a variable to hold our longest prefix, right? So yeah, the variable to hold our longest prefix, which is going to just be an empty string. And so we are going to say, if that's the case, then we're going to say another if function. If str at character I is equal to that, okay, since we're doing, we're not doing the minus 1, we're already doing the minus 1 length here, so it has to be equal to, right? Yeah. If we're not doing the minus 1 length here, then we'll not use it, equal to. But we're doing if str.character add I equals to come blah blah blah, then we want to do prefix plus com.I. But there's a better way of doing this. We can convert prefix to a string builder and then, kind of add a string builder there. But if not, then we leave prefix like that. So what this particular one does is that it only works, you only compare, you take for each, right, each string, it's going to compare against every, right? But once we have done it for the first one, do we just want to assign now, because this just takes the first string and assign, but when we're assigning, do we want to replace, right? Do we want to replace? So the idea is that for each string, right, that before we okay, before we assign it here, we need to check, right, if the length of the new string, I don't know if this understands. Okay, say, I know this is complicated. Say we have a prefix, right? After we've done the first iteration, a prefix that comes up to say, right, something like that. And then we compare another string that have kind of the same, you get, that have something like that, right? Another, and instead of M, it has a best, right? Something like that. Say, let's just say plus, right? So what will happen is that if we are replacing, this will work, but if this string say is just BL, but it only comes after this, then we are simply just appending BL here, right? Or worse, if we were to modify it in some other way, it will completely replace that and put BL, but that's not the longest one. It's a bit complicated. I know my explanation is a bit rusty. I'll get better with time. The idea of what we want to do is that we want to check if the current prefix length for each time we compare a new string, each time we meet a string where the start and the finish are the same, I mean the start letter is the same, each time we meet a string that the start letter is the same, and we do all this calculation before we assign to prefix, right? We want to check if what has been generated here is longer than what it already exists here. You understand? It's only when that's longer can we assign prefix? Can we assign that to prefix? So we have to have another string, say, right, string temp, right, equals to an empty string 2. Okay. Now, these are two different strings. Now, temp will be, this is what will happen. Temp will be temp. So instead of prefix here, we're going to do this assignment to temp, right? And then we're going to check if temp length is greater than prefix length, then we're going to assign temp to prefix. I hope this makes sense. So we're going to check if the new, okay, this doesn't go here. This goes out of the for loop. Yeah. So check if the new generated prefix is longer than the existing. Okay, and that's the idea. So each time we temporarily assign and then we generate, and whether or not it is longer, you understand, it doesn't matter whether it's longer. We want to do what? We want to clear the temporary, right? So I want to temp, right, equal to new. Okay, it doesn't matter. We want to again put it. So once it's finished generating the temp, if it assigns, fine. If it does not assign and is still continuing the traversing of the original array of strings and doing the comparing, for each new string that we are comparing against, we want to make sure that temp is empty. It starts as an empty string. You get? So that it's always empty. And so, all right. So. Yeah. Okay. And then, so let's check the solution that we have thus far. We traverse the original string, right? And then we do a second traversal. So we are taking the strings and we are comparing against the next string. So we'll compare it against itself, right? This is the problem here. Now, there's another problem here, is that by doing this, we literally are comparing it against itself, okay? So, technically, if we did not do this, if we use I, then we will start from I equals to 1, okay? But then we have to use all of those stuff here. So, we can just check here if string this is not okay. So if this, we can do a check there, but I say the best option here is to just do an int I, okay, but rather than I here we put G, right? You know what? Let's keep the flow. So rather than I would just put J. Right. Let's keep the flow. So it'll be STS character I. And this will be STS character I, STS character I, STS character I, STS character I. I'm sorry guys. Hold on. There's a mistake somewhere. Yeah, there is a mistake somewhere, I think. So we're comparing this against this. So STS.character I equals to character I. If we maintain that, I can just check. Let's put the if here. Yeah, I'm shooting myself in the leg with this one. But anyway, the idea is to check if comp the compare string dot equals to string, right? We want to just continue. I think is that what this is? Not to break it. Continue, jump to the next iteration. Let me see. Let me see. Let me see something. System that sorry. System dot out print line. Compare. Let me see something. Flow might so okay. Flow might make flower might make flower flow make might okay. It skips it. Yeah, that's what that does. Yep, this is what I wanted to check. Okay, let me see. And I was supposed to return prefix. That's weird. Okay. Oh yeah. Okay, so you see that, yeah. So your flower flow might make, which is interesting. Okay. I think we have solved something, but it's not a problem. Yeah, it's not a problem. If there is no common prefix, return an empty string. If So write a function to find the longest common prefix string amongst an array of in. Okay. Oh, okay. I see what I've done here. Okay. We have solved something else. Because the solution to this one is rather easy. But anyway, yeah. And this is an example. And by the way, this is what software engineering is all about. You see, we've solved a problem, but it's not a problem we're asked to solve. So I've spent 45 minutes on this one problem, and it's not a problem. So the string has to be common among all the strings, among all of them. So that's the one thing. Because you see, there's flow here and there's flow here, but because flow is not found on the third one, it was supposed to be flight here. Yeah. So it's flight here. Because flow, according to the output, the two, flow is not found on the third one, right? It's FL, which is flight. What happens is it doesn't get, because this is the longest common string. It's common with amongst two of the elements of this array, but not among all the elements of this array. This is the one that is common among all the elements of the array, which is what we solved was finding the longest common string amongst any given two elements of this array. That's common among the element of this array. So that's completely wrong for what we solved, but yeah, you can just take that. And this is kind of a long procedure and terrible. There is a simpler way. The next step I was supposed to do was to make this optimize and remove the multiple, find a much more cleaner approach to remove the multiple for loops, nested if functions and all that. But because we're finding the most common among all, what we can simply do is take the first one and compare against all, right? And so it's as easy. You know what? I am going to just comment this out. I'm going to comment that out. Yep. And then we're just going to return an empty string just to avoid the error. So what we'll do is yeah, it's a double for loop again. Something like that. There will be another for loop. Sorry. For I, just J, do like that. Yeah, is it? Basically, it's writing it for you. But again, there's a prefix, right? So it's going to be a string. I know some of you are looking at me and saying, what is he solving? But yeah, this is a prefix, and essentially we are doing this string result, and then what we are doing here is say is it found on all of it. Okay, let's keep it simple. What am I asking here? Okay, this is STS, I, right? see for me. Right. No. So no. So I want to start at character 1, right? And so rather, I want to do this. I want to say if s if the character s dot character add I minus 1. No. Oh, we have to traverse s2. Oh. Let's. So if we traverse the string, okay, let's try writing that down. So loop and compare the first character of the string of the first string of the array against the first character of the others. Okay. Let's add a for loop. I want to do x. Now, the idea of this is to early return basically. So early return, find, check if the first characters don't match, right? So that's the early return. So I want to go if s tears x, right, the char at I do X starts from 1. Then this X. Okay, we'll do this. To return an empty string. This takes care of early returns. Also, this takes care of return. If it's just one string, then we're going to return, yeah. Yeah, because the constraint says, yeah, the length is 1, which means you can also have one string. So if it's just one string, then I think it's just one. And then we check for early return. So, see, check return single string array, single element. Right? And then we do early return, and if it does not return early, then that means at least the first character matches on all. Then we can do prefix equals to, right, dot character at that, right? Oh, sorry. We can use string builder, but let's go generic for the time being. So essentially at this point, initialize string, sorry, initialize result string to the first character. Okay, string result equals to that. And now, since we're initializing the first string to the first character, we simply just want to use the first string and traverse through the rest. So first string, okay. But again, do we want to use the first string and traverse through the rest? Because here's the logic, okay? They say the length of each string is between these. Now, these two numbers can be different, right? And the most common prefix would depend on the shortest string. So, for example, if this was something like flowing, okay, and we compare with flower, let me say flowering, right, and we compare with flower, we can traverse using this one, but this is the most common. The most common is flow, yeah, right, because it's the one common among all. But flowering will pick up between these two. So we don't want to traverse using just the first. We want to traverse using the shortest string in this array. So the first thing is to find the length of the shortest string, right? So which of them has the longest length? So let's see if str's let's see if there is string.max. Yes, array string str.max. Okay. Okay. Now, okay. This is advanced Java. It takes a consumer, right? A comparable. Basically, you are checking for the maximum of the array string. So I think it's string.max. Oh, it's going to take the comparison to str's dot superstring comparator. Essentially, okay. I think we could do something here. Length here. Basically, this gets over the length. Let me see. Get the length of string, and then we're going to compare. So if we have if, we have to compare against max length. Okay. So, okay. Here's what's going to happen. We need to find the length of the shortest string in this array, right? Oh, okay. We don't need to find the length. Basically, if the character at where is it? We want to check. So where isn't the first one? No, the first one is always going to be there. But if there is a character at the end, so we want to stop where there is no longer a character, where the last string ends, where the shortest string ends. That's where we want to stop. So technically, we want to break. So we want to say if string.character is equal to 0. The first thing we want to check is if the string we are comparing at that position has a character at something. So we have to do if string character at end. this is interesting. Okay, I think my if function is interesting. We're always staying constant with 1, and then string at 1, at character at. Okay. So we are staying constant with the first string, and we're checking at the character, which this is wrong. This is wrong. So we want to stay constant with the first string. I think this is a double loop at the very least. Right, so it's a double loop. This is early return, sorry. Okay, yeah. I was wondering that. So yeah, okay. This makes sense now. So we want to make sure that there is a string. This is early return. I want to check out the first one. String x dot character at the first one. Yeah, that's good. And we want to make sure, this is where I want to check if the character, so remember we have s, right? And literally we want to check s, which is the first one. So this is a double loop. So we get the first loop early return. If it's not early return, then we want to initialize result as the first character. And then what we want to do is we want to loop through, staying stagnant with the first string, and then looping through every other string. So we want to loop, staying stagnant with the first string for I. But we just want for I we just want to stay for the first string for int or while true. Okay. For I. For into I equals to 1, I is equals to 1. Or just basically choose which one you want to go with. And then we want to say for int I equals to 1, I equals to less than 1, I want to do for j, I equals to less than 1. So we want to stay with the first one, we want to say technically equals if string I, but technically we want to stay with string 0, right? And then character at I, right? Yeah, string 0, character at I, and then we also want to have string j, character at j. string I, string J, character I. Yeah, exactly. Because we always want to compare the character at I. But before this, we want to make sure that character at I exists. So I say if string J character at I is not equal to no, I think no goes. Let me see. If string, sorry, if string J, right, dot character I, okay. Oh, I see. We can okay, so essentially for the character I, if string J dot length is less than I, there we go. That's it. So we're trying to find out that if the length of the string that we are traversing now is less than its index, which of the string where we are. So if this string J, right, that length is less than that, then so we want to put this is not, we want to only make sure that this goes if this, so we want to only make sure this goes if I is less than or equal to string J, right? I is less than or equal to string J, right? In essence, basically, where the shortest string stops, that's where we want to end this. If I is less than or equal to string J dot length and string S character at that, right, is equal to that, then we want to simply just append prefix, result result is sorry, plus equal to variable. Yeah, I know string data will be good. And then we just want to return result. I think that should do it. Let me see. Result. Not certain, but let's see. Oh, did I print that? Hold on. It's time the longest string print out. Result. And also, we want to make sure that the moment we meet the first, we break, right? Yeah. So result string, J. Okay, kind of. Let's see. It's weird. Just let's do this. We have to do the early return. 0. Can start at 0 yet, so I will comment this out for now. You cannot the editor was good, but the code gets bulky with it, and so we'll basically just do string equals to that, and yeah, I think that should be it. Oh yeah, also they should really comment out that I don't know if exception index for out of bounds for line blah 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 exception in main Java 01 24 equals to 0. Okay, I think me trying to do this thing is kind of a big deal. Equals to 0, so it starts from I. If I is less than or equals to, and then let's see a string of character I is 4 equals to 4. There's the break. Right? If I is less than or equals to STS dot J, yes, because we're trying to find a character. So basically, oh yeah, J minus 1. Okay, that makes sense now. I think okay. Actually, it's supposed to just. It's not supposed to give. So this is wrong. This is wrong. So okay. Okay, so that's good. So for I, which we're getting the first one equals to 0, I less than string of course, the first index dot length, I plus plus, yeah, and then we derivate the rest of the string because we're estimating just the first string. So we iterate the first string in the array. Iterate. Not integrate, iterate. Iterate the first string in the array, and then we iterate iterating the rest of the array, we're supposed to start add 1. Yeah. And that's why we have this thing here. And then there, this is good, but it is supposed to make sure that this is not supposed to go. Essentially, it's supposed to send an empty string. So we are iterating the first array, we're iterating the rest of the arrays, and then we're checking if it is the longest. Oh, okay. So we're going to have a boolean flag, which is going to be false, right? And yeah, we're going to do. So instead of, so when this is true, right? When this condition is true, we want to do true. We want to do flag equals to true, right? Okay. And then if after set condition is true, we want to do the for loop, sorry. If flag want to do this. Oh crap. Okay, essentially what we wanted to do was resort the string at j, right? And character at I. But technically we don't need that. We just need string at 0, character at I. Right? And that's what we need. So we flag that one each, they're supposed to be true. And then all of these. Technically, if we have to reverse this, then we'll do if this is greater than. Yeah, I'm doing just better coding here. If I is greater than all of this, right? Or this. If either one of these is true, it's not equal to. We want to, so we just put this true. We want to flag false, and then break. Then, so this one of the true. So just do flag true. Yeah. This remove. It is cleaner, it's much cleaner. Okay. So this I think is the final code. Initialize result, I think. Initialize result string to the first character. So just initialize result string. let's check that out. Okay, let's say right. That's interesting. Oh, okay. No, it's not even supposed to show L. It's not supposed to show L. Technically. Okay, these are the constraints. So yeah, these are the constraints, part of the constraints. So let's check that. Fine, good. Let's do float. Sorry. Yeah, don't blame me for the numbers. Good. Okay. Let's do these. Good. All right. So I think we have some kind of a solution to the test. Let's see. Also, let's test single string. Good. Okay. Do we have enough? Is this enough? Is this enough of a solution? Let's run the code. Oh, sorry. 1 minute. Let me arrange my network. So I got disconnected. Let's see if we can fix that now. Okay. Hope. Okay. I think I'm connected. Let's check that out. If that passes the test, okay. Case 1, case 2. Expected 5. Case 2. Good. Let's attempt to submit. All right. So we have a problem. Okay. It's taking a second here. There. So it passed 120 out of 123, which is interesting. And this is good because we understand that we have a problem, and I think the problem would be in the flag, because when we add the first one, then then we want to when we add the first one, flag, then result plus add that. Okay. Yeah. Okay, so we have double break. I think how this actually goes. Does that work? Does that still work in the local? What does double break? Oh yeah, this doesn't work. Okay, so we need a condition. Right, so we just have if not flag will break here. Right. Will break. And then we'll simply just return that. That should solve the problem. Yep. Since flag is always true, so if it's not flag, yeah, there we go. Ah, of course. So that's our result, and that's how bad it is. Yeah, but it's good because we solved it ourselves. It's a start. Okay. I think it's because of the double loop. Let's say memory analysis. 32%, not too bad. But yeah. Okay. So that is the solution for what we have. Okay. And basically works. Now we can optimize the code. Let's see if we can do anything better here. Essentially. So the remaining ones get this lost, right? All right, so we have this, and then it's basically factual. I think we're doing a lot of checks. We're doing an if statement to begin with for early return. And then there's a check here for flag. Anyway, okay, so that's the code we have. Let's see if there is a much more optimized version of it. Let's look at this one. Yeah. Let's take a look at this code. And basically this is a code. It starts with a prefix, string at 0. Yeah, of course. String at 0, str's 0. So I think it's just removing stuff. Or what? Let me see. For int I equals to 1, string.length I plus plus, yeah. So we traverse the string since we're already starting at 0, we should start at 1. Why is string? Okay. It is a double loop. Dot index of think that's that check to make sure that it's not exceeding the string length. This is it here, something like that. And then it says prefix equals to prefix dot substring 0 prefix dot length. If prefix dot empty. It's a better way of approach. Let's add GPT and see what it gives us. And then we'll end it for today. Okay? So we explained that time complexity of X. Initialize the prefix as the first string. For every other string in the array, check if it starts with the current prefix using index of. Prefix dot substring. So we see reduce it. It's a nifty function I didn't get to. Let me check. I didn't get to explore. I didn't get to explore that. Let me see. What did it say? So let's say index of prefix. How we compare that to the index. So the prefix is the first string. I will simply just compare that to the index, which is great, right? And then we remove the 1. So we want to see. And this is why I use Java. So basically I can just string J dot index of interesting index of as a string. What does it do? And did it for method call string dot index of. I don't exactly understand this. Returns the index within the string of the first occurrence of the specified substring, starting at the specified index. The return index is the smallest value k. How let's see. Okay, if no such value of k exists, then -1 is returned. I don't get it. Okay, 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 I see. That's a nifty trick. That's a nifty trick. Alright, we have a new stuff here, and this is good. This is good. Alright then. Comment your thoughts below on our solutions, like and share. And for those of you who already did this and saw this coming a mile away, it's great. We learn things every day. This is a new approach, actually. This makes sense, but kind of difficult for me to get there. So I'm happy I found this approach. Alright, like, share, and subscribe to the channel. See you next session. Bye.